Hello, we are going to be looking at how to simplify our rational exponents when the bases are going to be variables. So just some reminders that all answers need to be written in simplified radical form, and radicals only exist if I have a fractional exponent. So if my answer is not a fractional exponent, then I'm not going to have a radical. When multiplying and dividing, we are looking for something that they have in common. That's how I'm going to put our pieces together if I have more than one piece. So if I get to number 1, I'm looking for what they have in common. And these two have the same base. And we know our exponent rules. We've reviewed all of our exponent rules. So if I have the same base and I'm multiplying those same bases, I need to add the exponents. You can add the exponents however you want. You can pull out your calculator and you can add them. But if you're going to add them by hand, which is completely okay, you have to remember that to add fractions, you have to get a common denominator. You can't just do 2 plus 1 is 3, 3 plus 6 is 9, and tell me it's 3 over 9. You have to get a common denominator. So if you're not strong with those fraction skills, practice or pull out your calculator. It's not worth getting it wrong because you don't want to run over to your bag and get your calculator out, okay? So we're going to add 2/3 plus 1/6. That's going to be 5 over 6. When you look at this, you ask yourself, do I have a fractional exponent? If I have a fractional exponent, that means I need to rewrite it in radical form. Remember, the numerator is going to stay with the base inside the radical. The denominator is going to be the root on the radical. So this becomes the 6th root of x to the 5th power. For number 2, we have one base of x, and we have 3 halves, 6/5, and 10. This is a power to a power to a power. We had 2 pieces in number 1. We had the same base, and that's how we were going to add the exponents. In number 2, we don't have multiple pieces that we're putting together. That's why we didn't look for that common piece, because I only have one base. I don't have multiple bases. This is a power to a power, and when I have a power to a power, and we actually have a 3rd power, we are going to multiply those exponents. So this becomes 3 halves times 6/5 times 10, and when I multiply those 3 fractions out, I end up with x to the 18th power. 18, it's not a fraction. That means we don't have a radical. My answer is just x to the 18th power. When we look at number 3, we see the cube root of 2x squared, the cube root of 4x to the 7th. So the common piece that I have here is that we have the same root. That is how I'm going to put these 2 pieces together. Since they both are the cube root, I'm going to put everything underneath the same cube root. And I write it out in more steps than you probably would need to, just so that we can see where everything's coming from. So we've got 2 times 4, that's going to give us 8. X squared, x to the 7th, I'm multiplying like bases, so that becomes x to the 9th. Now when I go to simplify this, this is the cube root. That tells me that I need groups of 3 to move it to the outside. Well, 8 is really just 2 cubed. And we've got 9 x's. So I need groups of 3. I have a group of 3 2's. So the 2 goes to the outside. I have 9 x's. If I need it to be in groups of 3, if I were to write out all of these, I have a group of 3, a group of 3, a group of 3. So when I have 9 x's, I have 3 groups of 3. That is how I end up with 2x cubed. So we always got to make sure that we're simplifying all the way as well. For number 4, we have the same base. That is our common ground on how we're going to put these pieces together. We're going to start with one piece at a time. So I'm going to combine those numerators. because they have the same base that I'm multiplying, I'm going to add those exponents together. So when I add those exponents, 2/3 and 5/3, we can do that by hand because it already has a common denominator. We get 7/3. We still have that common denominator of x on top and bottom. Since we're dividing the like bases, that means that we are going to subtract the exponent 7/3 minus 3/4. 7/3 minus 3/4, again, use your calculator. It's going to be 19/12. Now at this point, I know that we're going to have to simplify because when I look at my fraction, it's 19/12. 19/12 is greater than 1. When my fraction is greater than 1, I know I have to simplify. But if not, we know we've got our 12th root, x to the 19th power. I need groups of 12 and I have 19. I have enough to pull a group out. I can pull one group of 12 out. And if I need 12 in a group and I have 19, that means that I am leaving 7 on the inside. But it's still the 12th root, x to the 7th power. Number 5, I've got a lot of different things that are the same. I've got the same base and I have the same root. I'm going to start off here with the same root. I can put these both under the same 5th root. And then I see that they have the same base. And when I have the same base, I can subtract those exponents. So 19 minus 4 is going to give us 15. And remember, if we play the who wins rule, the numerator is larger, so it's going to stay on top. I need groups of 5, and I have 15. We know that 15 makes exactly 3 groups of 5. That means I have no leftovers. If I don't have any leftovers, I don't have anything left inside of the radical. This comes to be x to the 3rd radical. No fraction, no radical. Number 6. So we've got two different pieces here. I've got the same base of x, and I've got the same base of y. So if I look at the x's first, we've got 5/3 and 1. Who wins? The top wins. So I have 5/3 minus 1. With the y's, I have a negative exponent. I'm going to move that to the top. Don't forget that this is really an exponential value of 1. So that becomes 1 plus 1/2. So my x is 5/3 minus 1. That gives me x to the 2/3. My y, 1 plus 1/2, is going to give me y to the 3/2. So this one's a little bit different. We're going to have two pieces here. We don't have any other common ground to put these pieces together. So this is going to be the cube root of x squared times the square root of y cubed. I need 2 and I have 3. I can actually simplify that a little bit more. I can pull out one group of y's with one y left on the inside. I needed 2 in a group. I had 3. This represents that one group of 2's with the one left over on the inside. Leftovers always go on the inside of the radicals. Now we're going to move on to rationalizing the denominator. Rationalizing the denominator is all about looking for your groups. How many do you need in a group? How many do you need to finish the group? So we know that we do rationalize in the denominator because we need to get rid of radicals in the bottom of our fraction. So if I'm looking at this, this tells me that I need 3 in a group. I only have 1x. What I want to do is I want to finish off that group because we know if I have a group of 3's, it all gets to move to the outside and there's no leftovers. If there's no leftovers, then there's no radical. So if I need 3 in a group and I only have 1, that means I'm missing 2. 1 and 2 is going to give me that group of 3's. So to keep my equation in balance, I'm going to multiply the top and bottom by that cube root of x squared. So the 5 is on the outside. It's going to stay on the outside. cube root of x squared. That's my new numerator. I'm going to write this out in more steps than we normally have to, just so that you're clear on where things come from. So that's the cube root. This is 1 and this is 2. That gives me 3. Remember, this is why we did it. We need 3. We now have 3. That means I can move exactly one group of 3's to the, or groups of x's to the outside. Now I've gotten rid of the radical on the bottom of my fraction, and I'm done. In number 2, we just need to break this up into two different pieces, into a numerator and a denominator. If we backtrack, in number 5, we had 2 fifth roots, and what we did is we went the other direction and we took 2 separate pieces and we put it under one radical. We're just doing the opposite here, and then we're breaking it into two different pieces. I need groups of 3, and I have 6. Well, that's nice. I have exactly 2 groups of 3, so I have 2 groups of those x's on the outside. Not so nice on the bottom. So I need 3, and I only have 2. I ask myself, how many am I missing? How many more y's do I need to get to that group of 3's? Well, I only need one more. I have 2. I'm only missing 1. So I multiply the top and bottom by that one y that I'm missing. So in my numerator, I have the x squared on the outside times the cube root of y. We don't have to write the 1. We know that's an assumed value. This one, I wrote it out. You don't have to. We now have that group of 3's, so I can write it as my one group of 3's there. If you like to write it in the 2 steps because it makes more sense to you, go ahead. All right, the last part of this is adding and subtracting. So when I am adding, think about adding like terms. You need to have like terms in order to combine your pieces together. To be like terms, you have to have the same root and the same base inside of that root. So this is perfect. I have the 5th root of y, I have the 5th root of y. If I'm adding these pieces together, I have 2 of them here and I have 7 of them here. I'm combining my like terms, so 2 plus 7 is going to give us 9 of those 5th roots of y. Think about it. If I had 2x and 7x, that would become 9x. You don't change what you're adding together, you're just changing the how many. Last one. So we're going to go ahead and start simplifying. So I've got to distribute that exponent. 2 squared is going to give me 4. Power to a power, I multiply 4 times 2 to get 8. 1/2 times 2 gives me 1y. Distribute over here. 32 times 1/4 gives us x to the 8th. 4 times 1/4 gives me y to the 1st. And after I multiply, notice how I have x to the 8th. Ooh. You should be yelling at me right now. 32 times 1/4 is not, it is 8. So then we have x to the 8th and y to the 1st, y to the 1st. After I multiplied it out, that gave me my like terms. So that's 4 plus 3. We have 7, x to the 8th, y to the 1st. All right, that is going to be it for our simplifying with variable bases.